Increases in temperature have negative effects on steel. As the temperature of the steel increases, changes occur in the steel's material properties. This presentation will go over girders under fire exposure, steel reinforced concrete columns, concrete filled steel tubular columns, and concrete filled steel composite columns. Steel possesses a very low resistance to fire exposure due to the following properties: high thermal conductivity, low specific heat, and faster degradation of strength with temperature. The strength and stiffness of steel decreases very rapidly when exposed to fire, which creates problems when the steel is needed for strength in structures. Different steel treatment techniques affect the behavior of a material and change its mechanical properties. Pre-stressing steel was chosen due to its prevalence in construction. To model fire exposure, the steel is heated to between 700 to 900 degrees Celsius, then allowed to cool. The steel tested was heated to 700 degrees Celsius, then allowed to cool to room temperature before testing. When pre-stressing steel, yield strength was reduced by 64.1%. With hot-rolled steel, yield strength was reduced by 15%. This is shown in the figure. When steel is below 700 degrees Celsius, there is no effect on modulus of elasticity. Changes only begin to take place in the steel from 700 to 900 degrees. After a temperature of 900 degrees Celsius, the modulus of elasticity was recorded to experience a significant decrease of up to 20%. Similar to the modulus of elasticity, no effects on the ultimate strain are seen until after 600 degrees Celsius. At 700 degrees, the ultimate strain increases up to 2.5 times compared to the unheated ultimate strain. The study of steel girders exposed to fire is important since failure of these beams are catastrophic. The thermal response of the steel girders is non-uniform due to the varying cross-sections of the flange and web. The figure shows the change in temperature of different cross-sections within the girder over time. The results of the varying temperature gradients within the girder result in non-uniform deflections, which decreases the load-bearing capacity of the girder. A case study indicates that most typical girders that are exposed to fire conditions experience failure within the first 30 to 35 minutes. When a girder fails, it usually does so in a V-shaped manner. This is due to large deflections resulting from large rotations at the girder ends, in addition to the crushing of concrete at the midspan region. Standard steel-reinforced concrete columns use a concrete cover to protect the steel. An H-shaped reinforcing steel beam is used in the center. In this study, steel-reinforced concrete columns were heated to 800 degrees Celsius. The reinforcing rebar in the columns experienced a temperature of 600 to 800 degrees Celsius, resulting in a 26.7% decrease in peak load that the steel could resist. The H-shaped central reinforcement becomes responsible for 12.4 times more of the load after the heating compared to before. This results in bending and yielding of the steel. As the temperature raises, concrete undergoes explosive spalling. When the concrete spalls, the previously covered steel is exposed to the heat. This increases the heat experienced by the steel and the loading on the steel after the heating with the decreased concrete. The figure shows the bent rebar, the weakened cross-section, and the buckled steel. Concrete-filled steel tubular columns. Concrete absorbs heat without deforming better than bare steel tubulars due to the concrete acting as a heat sink for the steel. For concrete-filled steel tubulars, it was found that increasing the heating duration time had little to no effect on the column's ductility or energy absorption capacities after the exposure. The concrete-filled beams after fire exposure decreased in their ability to resist lateral loads from an increase in ductility of the column. The coupling joints used to connect the beams to the columns were found to fail before the columns in a weak beam, strong column way which is desired. Circular columns were found to have greater energy absorption than square concrete-filled steel columns. Fire-resistant coatings for steel are classified as either expansion type or non-expansion type. An example of an expansion type fire-resistant coating is a carbon foam which expands when exposed to fire, protecting the steel beneath. An example of a non-expansion type of fire-resistant coating for steel is fire retardant. The level of fire protection is unrelated to its thickness, but must pass a fire-resisting coating test. In summary, fire drastically changes the mechanical properties of steel. Steel has little resistance to excessive heat. Girders exposed to extended periods of fire conditions fail due to large deflections and rotations which occur non-uniformly throughout the girder. Steel reinforced concrete columns exposed to fire undergo severe spalling, and fire-resistant coatings are sometimes used to minimize the effects that high temperatures have on steel.